Physics is not only the plural of physic, but is also an element of video games that we often take for granted. Although it's nearly impossible to replicate physics that can be equated in any way to real life as a result of atoms and triangles being quite different, physics engines attempt to find a manner in which we perceive the physics of a video game to be enjoyable in some way. To see why I say enjoyable and not accurate though, let's take a look at the actual physics of Terraria, because the game theory already did Mario's physics once every time he's been called at 3 AM.
Okay. Yeah, I think we should be safe in here.
Despite Terraria being a survival game, the in-game physics of kinematics, which is the movement of any given subject within the game including people, has an immense impact on the gameplay, but is also somewhat deceptive. From what I could find, each block in the game is about 2 by 2 feet, or 0.6 by 0.6 meters. The player character can jump a total of 6 blocks with no items equipped, which is the equivalent of 3.6 meters. Also, the player character himself is around 3 blocks high, or 1.8 meters, or 5 foot 9 inches. As a result of the footage I use being at 30 frames a second and the freefall motion taking up 12.5 frames from the zenith of the jump, we can get a time value for the motion of 0.417 seconds. We can then take this kinematic equation, solve for acceleration, and plug in our values for vertical displacement and time, ignoring velocity because it's equal to 0 at the beginning of the motion. That gets us an acceleration of about 41.406 meters per second squared, 4.22 times greater than Earth's gravity of 9.81 meters per second squared. That is 1.67 times the gravitational acceleration of Jupiter. If you were to be on a planet with this type of gravity, all the blood in your body would rush to your feet, killing you if you were on the planet for any extended duration of time. But why would Terraria do this, even though it's not very difficult to program an acceleration of 9.81 meters per second into the game in order to simulate the gravity of Earth? Well, to put it simply, it's fun. It's fun to fall faster than Earth's gravity because it means faster paced movement, with this being a major reason as to why a majority of games, and especially platformers, tend to increase their world's acceleration due to gravity. To expand upon this, Newton's law of universal gravitation states that gravitational force between two masses is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers, represented by this equation. Since the height from the surface of a large world to the bottom of the underworld is on average about 1800 blocks, or about 1080 meters, we can use this as the distance between the two subjects. We'll use the mass of an average male at the player character's height of 72.5 kilograms, and the force due to gravity previously calculated. Just a disclaimer, I know that the previous calculation was just the acceleration due to gravity and not the force between the two objects, but oftentimes the mass of a planet is so much greater than the subject that it's pulling on that the difference in gravitational force and acceleration is nearly negligible. Doing this, we end up with a planetary mass of 9.98 times 10 to the 15th power. Assuming Terraria's world to be a sphere, this gives us an average density of about 1,891,491.059 kilograms per meter cubed for Terraria's planet, 342.66 times the density of Earth. I would calculate the Schwarzschild radius of the planetary mass to see if this would result in the planet turning into a black hole, but there's no time for that. But if the same math applies to smaller worlds, no more King Slime. But hopefully this all paints a picture as to why video games can't be too accurate to real life if you want them to be any fun. This can also be demonstrated with the physics of dynamics in a game like Zelda Ocarina of Time, where you do things like push around blocks of rock larger than your body. If you don't remember enough of Newton's 3 laws of motion to get why this is, I'll give you a bit of a refresher. Newton's first law of motion is that of inertia, stating that an object at rest as well as traveling at a constant velocity or in motion will remain in those respective states until acted on by an unbalanced force. Newton's second law of motion states that the acceleration of a subject is directly proportional to the net force acting on the subject and inversely proportional to the mass of the object. This is where net force is equal to mass times acceleration is derived from. The third law of motion states that any force enacted on a subject is met with a force of an equal magnitude in opposite direction. The reason why anything moves at all is just because net forces are unbalanced. These laws, and especially Newton's second law, can be seen in Link pushing the block as shown in this force diagram. Because Link is able to push the block, the net force of the horizontal direction is unbalanced in the direction that the block is being pushed. This is due to Link being able to overcome the frictional forces acting on the block, with the force due to friction being equal to the frictional coefficient times the normal force, which is the force of which the ground exerts upward on the block as a result of the force of gravity pulling the block down, the normal force being a demonstration of Newton's third law. Of course, Zelda is an unrealistic depiction of this, considering elfmen likely wouldn't be able to push a block of such a mass, but elfmen aren't real anyway. Just goblins.
Goblins are real. Goblins are real.
Force can also be applied to circular motion in the form of centripetal force, which is the force pulling a subject towards the center of a circular motion. Something that can be seen in a video game such as Mario Kart, since drifting around corners still has a force pulling the cart towards the turning side. Also, at any point the direction of the velocity of the cart is actually tangent to the circular motion of the cart. This would explain why you immediately go in that direction when you get a boost, rather than being able to manipulate the path of your motion immediately. But even if you don't care about all those video game physics, at least we can all appreciate Sir Isaac Newton's winning performance in the 1704 Nintendo World Championship.
Who you gonna call when there's an animatronic bear? Come down to Freddy Fazbear Pizza Fredbear.